Saxon's Calculus Lesson 115 is partial fractions for the third time, and since I chose to not cover them the first two times, we're obviously not covering them the second time. Lesson 116 is derivatives of e to the x and natural log of x. Well, you already know those. Derivative of e to the x is e to the x, and natural log of x is 1 over x. And in the second part, they did derivative of sine x. And again, you already know what that is. So what they're doing is manipulating through and showing you a different way to work with the problem and get down to the same answer. Well, since it's already been proven one way, I didn't think you wanted to see a proof a second way, especially a proof that involved graphing and integrating and all kinds of fun stuff, and took like, I don't know, 2.5 pages. And then they did example 1, which I just felt was kind of silly, so all right, fine. And then part B was the proof of the derivative of sine x, and it was optional, and you really don't want to know it because we already know what that does, and it's basically using that standardized equation filled in with a lot of extra cosine minus 1s came from sine squareds, all that loveliness, and then a lot of limits to 0 getting thrown in there, only to get to finally prove to you that it's cosine of x. Okay, lesson 117 is proofs of the fundamental theorem and epsilon delta proofs. It's also the last lesson in the book. And part A was proof of the fundamental theorem, which again, page 572, they're showing you, you're talking about area under a curve, you're creating a rectangle, you're working down through, and they talk about a ceiling function on the bottom of 572. They continued the manipulation on 573. They remind you in the box what the fundamental theorem of integral calculus is, which we already know, is substituting in the boundaries, like the integration of a to b, you're subbing in the a, you're subbing in the b, and you're subtracting those, so you already know that. And then they do a whole bunch more manipulation with all of that loveliness. They're continuing on page 574, and they're showing you more graphing, more stuff on the number line for how you are like shifting the numbers. And then they continue on page 575 back with the original calculus derivative formula, f of x minus f of a different piece over top of the change, and then they throw in the limit part, and they finally get their answer. And then at the end, they just say, you get the answer that you would get when you plug in b and subtract the answer when you plugged in the lower a. Oh, great. And then which completes the proof. I just thought that was kind of funny. After all of that, they have completed the proof. And then part B was epsilon delta proofs. Again, it's a proof, and so I didn't think that you necessarily needed that either. There is a graph on page 576 where they're trying to help you understand the relationship between the dots and how they equate to the line, and then they do the box with the limit of a function, which you already understand the basics of the limits. Then they talk about the absolute value, giving you things that are greater than and less than a number, and they're done. Then they move into their final two examples, which is prove that the limit of x going to 2 of 2x plus 5 equals 9, and they throw it in, they do a little bit of manipulation with the greater than and less than, and they get their answer. And then they do the same thing in example 2, and I just didn't feel that any of that was extremely important for you. So I'm not officially covering the lesson.